Okay, so now we have number 22. It says graph and label the following equations on the same coordinate axes below with f of x, which is equal to 3 to the x power. So that's already graphed for us. So if I add a 1 on part A to it, it's just going to shift the whole graph up 1 unit. You can do a little tiny table here, and you can try a couple points for x, like 0 and 1, and just see that if I take 3 to the 0 power, that's 1, and 1 plus 1 is 2. If I take 3 to the first power, that's 3, and 3 plus 1 is 4. So plotting those points, see it goes through 0, 2 now instead of 0, 1, and it goes through 1, 4 now instead of 1, 3. Okay? And so your asymptote line as well, instead of it being the x-axis where y equals 0, it's going to be where y equals 1. So it's going to get closer and closer to that asymptote line. And so that's what the graph will look like. For part B, notice that it's now negative x up in the exponent. So again, I'm going to do a little table of values here. And I'm going to do when x is 0, 1, and negative 1. We'll just try those 3 points. So if I put 0 in there, it's still 3 to the 0 power, which is 1, and 1 plus 1 is 2. But now when I put 1 in there, it's 3 to the negative first power, which is 1/3. So now I have 1/3 plus 1, which is 1 1/3 or 4/3. If I put negative 1 in there, then it's 3 to the opposite of negative 1, which is 3 to the first power, or 3. So it's 3 plus 1, which is 4. So what that's going to do, well, let's just plot those points real quickly. It's 0, 2. Whoops, my blue graph moved, didn't it? When I shifted my, here, let me move this blue graph over again, if I can. Okay, it went through 0, 2, there we go, whoops, 0, 2, I don't know why it shifted. Okay, so 0, 2, and then 1, 4. Let me see if I can get those points. Well, it's not, there we go. Okay, I think it's more like that. Okay, so now let's do this next one, part B in green. So it goes through 0, 2, 1, 4/3, so 1, 1 1/3, and then negative 1, 4. Let's see, 1, 2, 3, 4. So right here. So notice that it's backwards now. It's going to be going this way, and it's going to get closer and closer to that asymptote where y equals 1 again. But that negative x in the exponent reflects it across the line where x equals 0 or the y-axis. Okay, so now what if I have x minus 1 up in the exponent? And this negative 3 down here is like negative 1 times 3 to the x minus 1 power. So let's do just a little table of values here. And let's try 0, 1, and negative 1 again. Okay, so if I put 0 in here for x, I'm going to have 0 minus 1, which is negative 1. And 3 to the negative first power is 1/3 times negative 1 is negative 1/3. Okay, and then if I put 1 up in there, I'm going to have 3 to the 1 minus 1 power, which is 0. So 3 to the 0 power, which is 1, and 1 times negative 1 is negative 1. And then if I put negative 1 up in there, I'm going to have negative 1 minus 1 in the exponent, which is negative 2. So 3 to the negative second power, which is 1/9, and 1/9 times negative 1 is negative 1/9. Okay, so let's plot those points. So 0, negative 1/3, 1, negative 1, and negative 1, negative 1/9. Okay, so what's happening here is it reflects it down instead of up. and it shifts it also to the right 1 unit. So you can see that the red line, it's been shifted over to the right. So instead of it being 1 at where x is 0, it's now -1, because it's the reflection of it, at +1 when x is 1. Okay, so for part D, we're going to do 3 to the x minus 1 power. So let's do just a little table of values here. So I'm going to do 0, 1, and -1 again. If I put 0 in for x, I'm going to have 3 to the 0 minus 1 power, which is -1. So 3 to the negative first power is 1/3. If I put 1 up in there, it's going to be 1 minus 1 is 0. So 3 to the 0 power, which is 1. And then if I put -1 in there, that's going to be 3 to the negative second power, which is 1/9. So what this one does, in essence, is it shifts that graph of the original function, y f of x equals 3 to the x. It's going to shift it to the right 1 unit. So I now have, let's plot those points. So 0, 1/3. 1, 1. So see, instead of it being 1 at 0, it's now 1 at 1 when x is 1. So it's shifting it to the right 1 unit. And then -1, 1/9. Okay, so again, it's approaching the asymptote of where y equals 0 or the x-axis. Okay. So now let's look at number 23. It says, find the following sum. Assume that this is an arithmetic sequence. Okay, so this is where you are going to want to look at that reference sheet. It's in the back. And again, you'll get this on your test. And the two equations that we need off of that for an arithmetic sequence are these. A sub n is equal to a sub 1 plus n minus 1 times d. And then we also need the sum of an arithmetic sequence, so s sub n, which is equal to n over 2 times a sub 1 plus a sub n. So we need to know the first term and the last term, and we need to know what n is in order to find the arithmetic sum. Okay, so a sub 1 here is the very first term in the sequence, which is -1. A sub n here is 75. Okay, but we don't know what n is. We don't know how many terms are in this sequence. So that's the missing piece that we don't know here. See, we know what a sub 1 is, we know what a sub n is, but we don't know n. Okay, so to find n, I'm going to use the top equation, and the top equation says a sub n is equal to a sub 1 plus n minus 1 times d. What is d in this case? D, remember, is what number you are adding from one term to get to the next term, because with an arithmetic sequence you are adding a term each time. Okay, so let's just plug these values in and we will figure that out. Well, first of all, let's figure out what d is. So to go from -1 to 3, it looks like I'm adding 4. To go from 3 to 7, yeah, I'm adding 4. So that means my d is 4. Okay, so my a sub n here is 75 is equal to a sub 1, which was -1, plus n minus 1, I'm trying to figure out what n is, times d, which is 4. Okay, so now let's just solve this for n. So I'm going to add 1 to both sides, so I get 76 is equal to n minus 1 times 4. I'm now going to divide both sides by 4. So the 4's cancel, and I get n minus 1 on the right side, but I'm going to move it to the left side, is equal to 76 divided by 4 is 19. So n is 20, adding 1 to both sides. Okay, so now I can go back to my summation equation, and I can plug in all the values that I know in order to figure out what the sum of this sequence is, this arithmetic sequence. Okay, so I've got s sub n the sum, is equal to n. I now know that n is 20 divided by 2 times a sub 1, which is negative 1, plus a sub n, which is 75. Okay, so we'll just simplify this. So 20 divided by 2 is 10, and negative 1 plus 75 is 74. And so that gives me 740. Okay, number 24. Okay, so again, this uses the formula off of the reference sheet. It's the very bottom formula. So that's the formula I'm going to be using. So I want to expand using the binomial theorem. Okay, so in this example, my x is 2x. Okay, this is your x right here. My a is this, so my a is negative 3. And my n here is 5. Okay, so to expand this out, it says that x plus a to the nth power is equal to the following. So I first of all do this bracket thing, and I take n, which is 5, taken 0 at a time, times x, which is 2x in this case, to the nth power, which is 5, plus, and now I just count slowly up on the bottom numbers. So this number on the bottom is now going to become 1. And now I have to start inserting my a. So my a is negative 3 times x again, which is 2x in this case. So 2x to the 4th power, plus, and now it's 5 taken 2 at a time, times a, which is negative 3 to the 2nd power. Notice how those exponents are increasing while the other exponents, the x, or the 2x in this case, are decreasing. Okay, so negative 3 to the 2nd power, 2x to the 3rd power, plus 5 taken 3 at a time, times a, which is negative 3 to the 3rd power, times x, which is 2x to the 2nd power, plus, let's see, and I'm not going to have a lot of space here, but I'll just put it down here below anyway. So 5 taken 4 at a time, times a, negative 3 to the 4th power, times 2x to the 1st power, plus 5 taken 5 at a time, times a, which is negative 3 to the 5th power, times 2x to the 0 power, or you can just leave that off, since that just equals 1. Okay, so since I'm out of space here, I'm going to write it up above. So remember that 5 taken 0 at a time, when you do that, when you've got 0 on the bottom, it's just going to be a 1. So this is just 1 times 2x to the 5th. 2 to the 5th is 32, and then x to the 5th, plus 5 taken 1 at a time. When you have a 1 on the bottom, and you can work that out, just remember the formula for n taken j at a time, which is right above the binomial theorem on the reference sheet. So 5 taken 1 at a time, I know, is just going to be 5. It's whatever that top number is when the bottom number is a 1. So that's going to be 5 times negative 3 times 2 to the 4th power. So 2x to the 4th power is 2 to the 4th is 16, and x to the 4th power. Plus, now I need to figure out what 5 taken 2 at a time is. So let's just do a little aside thing on that. Let's see, let's just do that over here, because I don't have room anywhere else. Okay, so 5 taken 2 at a time. So remember that that's 5 factorial divided by 2 factorial times 5 minus 2 factorial. Okay, so 5 factorial means 5 times 4 times 3 factorial, and 2 factorial is just 2 times 1 times, and 5 minus 2 is 3 factorial, so 3 factorial. So then I can reduce my 3 factorials, and I can reduce my 2 with my 4, and it ends up being 10. Okay, if you'll recall, we did that one in class together, so that turned out to be 10. Okay, so that's 10 times, and now I have negative 3 squared, which is 9, times 2x to the third, which is 8x to the third, plus, and now I've got to do 5 taking 3 at a time. And again, you could figure that one out. I'm not going to do it here because we actually did it in class last time. So that turned out to be 10 as well. Okay, so that one's 10. So 5 taken 3 at a time is 10 again. Times negative 3 to the third is negative 27. Times 2x squared is 4x squared. Plus, and now I'm down to 5 taken 4 at a time. And when the number is 1 less than the top number, then it turns out to just be that top number. So it's 5. And again, you can work that out yourself to see what that is. So that's 5 times negative 3 to the 4th power, which is 81, times 2x to the 1st power, so 2x. Plus, and then 5 taken 5 at a time is just 1, times, whoops, 1 times negative 3 to the 5th power, which is, I don't have my answer sheet here with me. Let's see. I think it's 243. Negative 243, but let me just try it here real quick on the calculator. Okay, so I'm doing negative 3 to the 5th power. Yeah, it's negative 243. So times negative 243 times 2x to the 0 power, so that's just 1. Okay, so now let's work this all out. So 1 times 32 is 32x to the 5th, plus 5 times negative 3 is negative 15 times 16 is negative 240, x to the 4th, plus 10 times 9 is 90 times 8 is 720, x to the 3rd, plus 10 times negative 27, so that's going to be negative 270 times 4, which is negative 1080 x to the 3rd, or x squared, plus 5 times 81, so 5 times 81 times 2 is 810 x, and then 1 times negative 243 times 1 is negative 243. Okay, now remember that when you work these out, you should have one more than n number of terms. So since n was 5, I should have 6 terms in my answer. So let's count them. 1, 2, 3, 4, 5, 6. Yeah. My exponents of x should be counting down, so they go 5, 4, 3, 2, 1, and then x to the 0. Okay, good. And so it looks like we did a, oh, and every other one, because there's my a is a negative, every other one will be a negative. So you'll notice that that's in there as well. Okay, so now let's look at number 25. Find the 5th term of the geometric sequence with the first term equal to 6,561 and a common ratio of negative 1/3. Okay, so now you're going to use the next two equations for your sequences, which is a sub n equals a sub 1 times r to the n minus 1 power, where r does not equal 0, and then s sub n is equal to a sub 1 times 1 minus r to the nth power over 1 minus r. Okay, so my r in this case is the common ratio, so that's my r, which is negative 1/3. My a sub 1 here is 6,561, and I am trying to find the 5th term, so n is going to be 5. Okay, so what we can do is we're going to do this a sub n, so I'm trying to find the 5th term of the geometric sequence. The first term, a sub 1, is 6,561 times r, which is negative 1/3, to the n, which is 5 minus 1 power. Okay, so let's just work that out and see what we get. So let me do that on the calculator here. So 6561 times parenthesis negative 1/3 parenthesis taken to the 4th power. And that gives us 81. Okay, last question. We want to graph this ellipse. Okay, so it's in the form that we want where it's set equal to 1. You've got the equations for the formula there. Remember that your center is at H, K. So my H here is 2, my K is negative 2, because it has to be X minus a number and Y minus a number. Since it's Y plus, it's going to be negative 2. So my center's at 2, negative 2, right here. And in an ellipse, A is always the larger value on the bottom. So notice that 25 is larger than 16. So 25 is A squared, so that means A is just 5. Remember that the 25 is A squared. B is the square root of 16, which is 4, because that 16 is 4 squared. So since A is underneath the Y squared, that means I'm going to go parallel to the Y axis from the center. I'm going to go up 5 units, so 1, 2, 3, 4, 5, and then down 5 units, 1, 2, 3, 4, 5 from the center. Those are my 2 vertices. Okay, so let's list what the vertices are. This is the center. Vertices. Okay, so they, in this case, are at 2, 3, and 2, negative, what is that, negative 7. Okay, so the B is how far out you're going to go on parallel to the x-axis then. So from my center, I'm going to go right and left 4 units. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so now I can draw in my ellipse. It looks actually wider than it does tall, where really, in reality, it's taller than it is wide. It's just that my graph, the squares, you can tell when you look at each square, they're actually wider than they are tall. So that's the reason why it looks kind of weird. But the next thing we need to do is we need to find where the foci are. And they tell us on the formula sheet that C squared is equal to A squared minus B squared. So A squared is this, 25. B squared is the 16. So when I subtract, I get 9. That's what C squared is. So C is just 3. So that means that from my center, that's the distance from the center, parallel, or it's in line with the vertices. So I'm going to go, let's see, I moved my graph just a tiny bit. Let me see if I can fix that. There we go. I'm going to go from the center 3 units up and 3 units down. So 1, 2, 3, and 1, 2, 3. There are my foci. So my foci, then, if I list those points, are at 2, 1, and at 2, negative 5. It should be. Okay. And we're done.